Hi, I'm Christine. This experiment I was doing today was to separate acids, base, and neutral components from my unknown mixture. So using the extraction technique, bases and neutral components were found and then separated out from the mixture. So in order to identify the two components, the melting point was taken to determine the identity of the components. So this is my flow chart. I made this by hand, and so that I can show like every single steps of what I did. And so like just overall what I did is like after the separation, I measured the weights of the components and measured the melting points of each of the components I collected. So at the end, I found my unknown was containing the acids, petroleic acids, and then the neutral component, which is the benzyl. So, okay, next slide. I'm going to talk about the materials I use in the lab. So, in these pictures, I use a distillating receiver and where I dissolve my unknown mixture with diethyl ether. And also the extracted acids and bases aqueous layer, they were deposited into two of these centrifugal tubes with the clean pipettes, the pipettes in the back. So now let's talk about what kind of chemicals we use in this lab. So the most important thing is the solvent. The solvent used in this lab was the diethyl ether. Diethyl ether is a colorless liquid, and then its boiling point is 34.6 Celsius degree. Diethyl ether is really flammable, and it will cause like the irritant of eye and skin. So we need to be careful when we're doing lab with diethyl ether, especially when later in the lab we're gonna when I did the evaporation. So diethyl ether should be disposed in a non-halogenated waste container. So for sodium hydroxide and hydrochloric acids, they are colorless liquid, and then they may cause like irritant of the eye and skin. So for hydrochloric acids and then sodium hydroxide, they should be disposed in the sink with water. Sodium sulfate was the drying agent we used in the lab in the isolation of the neutral component. It's like this is a white solid thing. Yeah, it's a white solid chemicals. It may cause irritant to the eye, and it should go into the trash can. Okay, next one is I'm gonna talk about my apparatus. Hirsch funnel was used to filter the precipitate I collected, and then melt temperature and the capillary tube are used to measure the melting point of the unknowns. So now we got everything ready. Let's talk about like the secret of extraction. So let's get some background about extraction. So extraction is widely used in the nuclear processing. So I got this from Wikipedia. So extraction can be used in the production of the fine organic components, process of perfumes, and production of vegetable oils and some other industries. So the unknown I have today, it might contain like organic components that have like the acids or bases functional groups like carboxylic acids and amino groups. So again, today we use the difference in solubility to separate the components. Organic components, they are insoluble in water, but then they are soluble in diethyl ether because diethyl ether is a less polar organic solvent than water. So diethyl ether is less polar than water. So let's talk about the procedure and then the theory. Okay, after we add the hydrochloric acids, to the ether solvent here in the distilling receiver, the basic component will be protonate and become ionic salt, which is this one. So now the basic component is in ionic salt will be was soluble in water, but then insoluble in the ether, which just means like the basic component will stay in the aqueous layer. So this applies same for the acidic component. If the acidic component which was soluble in water was then deprotonate by adding base, which is the sodium hydroxide. So always remember the stopper needs to be placed on the distilling receiver if you are not adding anything, because the either evaporate really fast under the fume hood. So now for the extraction of the acidic component, we take out the aqueous layer from the distilling receiver and then deposit into this centrifuge tube. So the aqueous layer with the acidic component in the ionic form was taken out. Using the same solubility rule, by adding the hydrochloric acids to the aqueous solution, the salt of the acidic component was then protonate, and now it is insoluble in the water. That's why you can see a lot of like a white precipitate form in the centrifuge tube. The precipitate was then filtered out and kept in the fill hood to dry. So, but in my unknown, I didn't get a basic component, I got acidic component. So now the last step is to get the neutral component. The neutral component was left in the ether solvent throughout the whole extraction with the basis and acid solution, because the neutral component has no like acid or like basis functional group. So at the end, the neutral component was recovered by evaporating ether solvent on a steam bath. I didn't take a picture of a steam bath, so this is what I have, and so in order to avoid the ether gets too, and also be careful, just trying to avoid the ether gets too hot or it will catch on fire. Also, in the evaporation, a dry agent of the sodium sulfate was used to take up any water in the ether. So at the end, and then I found my neutral component in my unknown. You can see some like white precipitate in it. At the end, the melting point of the unknown, the acidic component, and the neutral component were then measured in order to identify the components. So now comes my result table. The mass of my unknown starting at 0.1014 grams. And then after I measure the weight of my acidic component and then my neutral component, I calculate the percent recovery as 75.8%. So the mass of the acidic component was like 0.044 grams. The mass of the basic component was 0.0329. I found my acidic component melting point was 178 Celsius degree, and I also found my neutral component. Is not right. I also found my neutral component melting point was 95 Celsius degrees. I got so I decided to say that my acidic component was petroleoic acid and my neutral component was benzoyl. But then I got my acidic component right, but I got my neutral component wrong. the experimental melting point was lower than the actual component melting point because the neutral component collected may be contaminated. So the component I got was not 100% pure. So that's all for this lab. Thank you.